So a couple more examples with finding intervals of increasing and decreasing. So I have f of x is x to the 2/3 power. F prime of x is 2/3 x to the negative 1/3 power. So if I just rewrite this a little bit to clean it up, it would be 2/3 x to the 1/3. So nothing makes it 0, but 0 makes it undefined. So my critical number is x is equal to 0. So I put 0 on my number line. If I pick something to the left, I'll use -1. And to the right, I'm going to use +1. So the cube root of -1, which is what that x to the 1/3 means, is -1. So that would give me a negative 2/3. When I plug in 1, I get a positive 2/3. So my function is decreasing from -infinity to 0, and it's increasing from 0 to infinity. And the graph of this particular function looks like this. Excuse me. So we know the derivative doesn't exist there because we have that sharp turn. Alright, my next one, we have f of x is equal to x plus 1/x. So find the derivative. We get 1. Remember that 1/x is the same as x to the -1 power. So that would give me -1 x to the -2 power. So 1 minus 1/x squared. Well, I want to know where the function is 0 and undefined. So it's easier if I get a common denominator and actually combine these two. So I'm going to multiply this first one by x squared over x squared. And that gives me x squared minus 1 when I put these two together, and then the denominator is x squared. So I can factor that numerator. And I end up with x minus 1 times x plus 1 over x squared. So my critical numbers are 1, -1, and 0. So I'm back to my number line, and I have to pick values in between here. So here I'm going to pick a -2. Here I'm going to pick a -0.5. Here I'm going to put a +0.5. And then this interval I'm going to pick 2. So if I pick -2, the bottom is always squared, so I don't really have to worry about that. It's always going to be positive. So I'm really just having to focus on the top. So when I plug in -2, I get -3 times -1. A negative times a negative gives me a positive value. When I pick -0.5, that would give me